Hi, my name is Lisa Richter. I'm Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Maybe you're here and you are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteers who have crowdsourced a best practices manual to help system integrators scale their businesses. In fact, the BP manual released the latest version about a year ago, and they are already planning the next version. CSIA also offers a certification program and other resources, including professional development, learning from peers, and access to vetted services companies like financial, insurance, legal, who understand an SI's unique business needs. Plus, CSIA is launching a new learning hub, which is an online platform with content and playlists that have been sourced and vetted by seasoned system integrators to help our members get their teams up to speed quickly. Think of it kind of like Spotify. All the content is there, but imagine having a personal DJ who spent over 20 years getting to know your preferences and tailoring the perfect playlist just for you. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, and monitor industry trends and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps system integrators, industry suppliers, and manufacturers connect and do business. Yana, the next slide, please. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. Next slide, please, Yana. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources, from accounting to sales to operations to training, 365 days a year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. If you are currently a member, thank you. Next slide, please, Yana. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's just a great way to hear what your peers are up to. Next slide, Yana. One last housekeeping note before I turn it over to today's speaker. If you have any questions during the presentation, please use the Q&A feature in Zoom. There's chat as well. You're welcome to use the chat, but if you have a question, please use the Q&A feature. It just helps us stay organized. If there's stuff in both places, we have to kind of try and toggle between the two of them. So that just helps us out. We are recording the session, and you will get a link to the recording in the next day or so. At this time, I'm turning it over to today's speaker. Mike, take it away.
Today, good morning. My name is Mike Brost. I'm a lead solution architect with Aviva. We're going to talk about constructing a defensible control system and the engineering required to make that happen. Education as a chemical engineer. I've been in industry for a while as control system engineering, process engineering, and manufacturing management. Since 1996, I've been with Aviva, Schneider, and Vensis Wonderware as a global solution architect on the monitor control business unit of Aviva, focusing on cybersecurity, solution architectures for customers. So as we talk about, look at this, I'd like to establish a kind of a threat landscape for control systems design. So I'm going to use some analogies, right? This is not, but like, control systems are not homogeneous, and that's one of the biggest things I see that happen is we treat everything in the control system as the same. So consider, a ballistic missile submarine, right? It's a little on the extreme, I admit, but it gets the point across. Essentially, there's zero threat of intrusion of that, right? It's sitting there, 800 feet below the surface of the ocean, right? No one's swimming down, knocking on the door, and trying to get in. Why do we put two launch keys in the submarine, right? Because as morbid as it may sound, to make a decision to launch a nuclear missile, we want to have a multi-actor authentication required. Two sane people must agree to do this. But does using the galley require the same level of authentication? Of course not. That would be ridiculous. So our control systems need to have the ability to differentiate who's allowed to do what against what, right? Just because you can change the bottling line from grape soda to cherry soda as a schedule would demand doesn't mean you can shut off the ventilation fans to keep the operators healthy. Doesn't mean you can open a waste gate to put waste material into the city sewer system. And there's lots of threats that we have to worry about. And they take various forms, from phishing and lack of domain isolation. You got firewalls and DMZs, but most of this stuff, if you in any sort of large organization, is really outside the scope of the control systems engineer. These are all controlled by the IT department. And so what we want to do is focus on what happens inside of the SCADA system, because most cybersecurity discussions really focus on all this stuff, but just ignore the SCADA system in general and look at things on the exterior of that, not how things are happening inside of that. So one of the big things is that the SCADA system is typically connected to the IT department, and not that but that's who you have to protect the SCADA system from. It's not necessarily that the IT department is bad or evil or anything like that. It's just that that's your threat vector. Your threat vector is coming from them. So here's an example. This is a pretty famous one, Colonial Pipeline ransomware attack, right? The business system was breached with an old VPN account and password. The pipeline control system was never penetrated. But the inability to protect the control system from the business system domain caused them to have to shut down the whole pipeline for fear of it being breached, right? Multi-factor authentication could have helped. Domain isolation would have been better. Being able to have a single point of disconnect between those systems would have been really ideal. And eventually a ransom was paid, and an FBI recovered part of it. Good for them, but it should never have happened. And then the other thing about control systems is that your greatest threat to the control system is the person that you give the authorization to, Joe the operator, or the authenticated actor. They can act inappropriately. They can be confused. They can be disgruntled. They can do things maliciously. They could be threatened. All kinds of things can drive that human behavior. So here's an example. On Saturday, January 13th, 2018, 8:07 a.m., a guy at the command and control center in the island of Oahu issued an emergency alert to every cell phone, radio station, and television in the state of Hawaii, basically telling them that everybody had 10 minutes to live. And, he didn't violate any security policy to do this. He just did it on his own. And obviously 38 minutes and 13 seconds later, they were able to issue a retraction. But in the meantime, pandemonium kind of existed. People are going around, where's the shelter? Or is the surf up? What's my last wave? So the point being here is that there should have been more than one person to authorize this. So as we look at this, right, the only real way to ensure security of a control system is using certificates. And the users of this control system must first get authenticated. They must establish themselves as a valid user in the control system. It should not be a generic connection, right? You shouldn't have to have one user that logs in for everybody. It'd be like us if we had one email account and the entire company used the same email account, right? So once in, then we must determine what that person is authorized to do. What pieces of the control system can they manipulate? And in some cases, they need to get approval to perform that action, right? Someone must approve that activity. And everything they do must be archived in a write once immutable logging mechanism that's in 21 CFR Part 11 compliant. The most important thing is that commands need to be enforced at the destination, not at the origin, right? And that should all be done completely independent of client configuration or protocol used. Just because you make a connection with some protocol doesn't mean you can bypass the security model, right? And obviously, we must have a securely engineered network segmentation and intrusion protection on top of this, but this is important within inside the control system itself. So we get a lot of discussion that I get involved with, and we talk about port restrictions, but the bottom line is that all software needs ports to communicate. And think of it as an analogy to an office building with about 64,000 telephones. You can restrict it to only 10 phones in the building you can call. But who is answering the phone when you make that call? Who are you talking to? Yes, fewer ports simplifies firewall configuration, simplifies administration, but sole reliance on port restrictions is a false sense of security. Certificates can ensure whom or what is picking up the phone. And there's lots of protocols that we have to deal with in the industrial world, right? There's device-specific protocols, and there's also more industry standard or generic protocols such as OPC UA, DEA, MQTT, others. But most of these protocols, in fact, nearly all of them, only can control access or no access. They can't differentiate once the connection is made between what you're allowed to write to or what you're allowed to command. And OPC-UA actually has this in their specification, but it's optional and it's highly ignored. I don't know of any vendor that actually supports it in the UA specification. But to secure devices and communication servers, this is really the most vulnerable part of the control system. Devices are very indiscriminate. They typically, in most cases, require a properly formatted string message. You know, if it's a Modbus type device, it just got to build a message correctly, right? So access should only be granted on a needed basis, right? Write access should be granted on a per business need. If you need to write to certain things, you shouldn't be able to write to anything, right? And sometimes you want authorization and confirmation on selected writes. Secured, meaning that you have to revalidate yourself as the user on the keyboard versus just have been logged in 20 minutes ago. And verified writes means a separate user who has verifiable permissions needs to be able to confirm that your write is acceptable. And all writes from any interactive source must be logged. Not configurable, shouldn't be a checkbox on a tag, and it should be logged independent of whatever client technology. So if I use another vendor's HMI, or I use a protocol, or I use anything else, the logging should still occur. And it's important to understand also that, programming, modification, and configuration access should only be granted when needed, right? Only from known locations, known endpoints. And dedicated workstations with this capability should be denied interactive login during normal operation, because think of yourself as if you were FDA validated, right? You can't be modifying the system willy-nilly. You must have a procedure or a process involved to make changes. And when we look at the requirements of this, a supervisory right, which is a commandable right in the SCADA system, the user credential, not the actual credentials, but a token of who that user is, should be sent with the right. When that right gets to a destination, it should authorize if that person is allowed to issue that command. And that destination could be configured to demand additional authentication or even verification before accepting the right. This should all be done with a single point of configuration. Shouldn't have multiple places to do this. And modification should not require the client application to be restarted. Now, graphic level security is a desirable thing, but it's not defensible, right? Yes, it enhances your operator experience, restricts visibility, reduces confusion. But if that's all you have, it's easily bypassed by different clients, graphics, access protocols, right? If I come in with a protocol, my graphics completely out of the picture. And it's impossible to maintain. Everything is too many configuration points because this stuff is typically implemented by a condition placed on the graphic, or as I like to call it, the cartoon, which has an animation link. And when we're getting into more and more needs for sharing information out of the control system to the business network or even beyond the business network into the cloud, right? And when we do that, we shouldn't allow these external environments to be able to reach in and decide what data they want to grab. All communication should be originated from the control domain. It should be secured with certificate-based TLS encryption. We should have domain isolation between these environments. No business domain user should be able to access the control domain. We want to minimize the footprint of write access. And so all public interfaces that you have should be in a DMZ so that you can disconnect yourself from the DMZ if necessary. And these things should not be able to bypass the security level that you've put inside your control system. And as we move data into the cloud, again, only the control domain should be able to originate this communication. Should not be able to teach the cloud how to reach in and grab data out of your control system. Tablets, browsers, and phones, which we want to share information to, are cloud-based devices. And they should not be allowed to breach the intrusion protections in place. We should be able to send our data into the cloud without having a phone having to reach in and touch the control system domain. And what is shared should not be able to be changed by anything external to the control system. One of the greatest risks of sending data to the cloud is that someone intercepts it, someone changes it, and then we have false information that we make decisions on. So the transmission must be bound to the transmitting entity. So I just can't unplug that computer, change its node, put in a different one, give it the same node name, plug it in, and next thing you know, I'm sending the same values, right? So it should be certificate-based, locked to a transmitting entity. And all our intrusion protection that we put in place, typically we have at least probably 3 firewalls. I've got a firewall on top of the control system, a DMZ, a firewall on top of the DMZ, the business system, a firewall on top of the business system. We should be able to keep all that intrusion protections in place without having to punch a hole through all 3 firewalls to be able to get access to a 443 port, which gets us to the cloud. All right, so as looking at Aviva's approach to cybersecurity, and I'll be the first to tell you, it's not the only approach, but it's understanding how we do it is kind of helpful. So we've taken this very secure. We've been cybersecure certified we're the first in the industrial world to ever have the ISA secure certification. Software development life cycles are all managed and maintained with very robust SDL procedures. We have a very active cybersecurity environment for questions, incidents, results, collaborate with a lot of other external resources. Customer has a Security Central website and related questions. We put all the Microsoft patches, for instance, up there and give information about what product vulnerabilities are and what updates are done. So all that's done within about 15 days as a maximum of release of any sort of security update. So as we implement certificates, the big problem with certificates is that they're hard to manage. The one thing about all certificates is that they expire. And now typically they expire at the absolute worst time. So you need a strategy for managing certificates. So with Aviva, we actually have a service that you can implement. It's called System Management Server. It's a service that will ensure all the certificates get refreshed. They get managed centrally. So even if you use your own purchase certificate, you can load one place to load it. It will distribute it to a multi-node industrial control system. Those certificates are available for anything else to consume as well. And it's just one central management place. This can automatically generate those certificates, or you can choose to get externally purchased certificates and load them in. Certificates get refreshed every month and they last for 18 months. So it's very not a high risk of if you can't talk to the system management server, it won't cause you any problems. And there's nothing magic about these certificates. They're just the same certificates you would have in the complete certificate store that exists in your computer's operating system. So our Premier SCADA system, known as System Platform, is based on object-based model. And so objects have attributes and attributes have permissions. But on top of that, we have a robust security model in development. So you can control who's allowed to do what, who's allowed to do different things. Are you allowed to bring new computers into the SCADA system? Can you export content out of this and take it home with you? Can you do any sort of modifications or changes to various things that are involved? And then in runtime, there's a set of operational permissions. So there's groups you can create, and then within each group, you can control who can manage alarms with various aspects, sub-aspects of alarming, such as shelving or modification of states, acknowledging alarms. We have three main operational characteristics. They're called configure, operate, and tune. Operate and tune are just two parallel type things. As a subset of operate, there's a secured right and a verified right. And configure is kind of a different way. It's when you have attributes or tags in this control system that are related to each other, such as scaling constants. In our case, our scaling algorithm has six constants that you can use. You don't want to modify 2 or 3 of them and have it interpret before you modify all of them. So configure is a configuration of security that says we have to be able to complete the changes on all these guys before we accept the change. And verify is just, I can be the one to verify right. A verifier must be separate from the originator of the right command. So we take those permissions. We do have one called free access, which means we don't care who the logged in user is, but you have to be legitimately logged in. There's no right that can occur without a authorized authenticated user. Operate, and as a subset of operate, there's a secured right and a verified right. Tune, configure, and read only means just what it says. No user initiated action can write to this value. And if demanded, the system will demand that you re-authenticate yourself. You can put comments in the right and come up with a demanded verification of you're actually the one sitting in front of the keyboard. You just didn't walk away from your workstation. So we put our permission requirements on attributes, and then we take the objects that those attributes are a member of and put them in groups. You can create as many groups as you want, and then the security group determines what a given role will give against that collection of objects in that group. And then users can be defined in the SCADA system itself. Users can come from an Active Directory or even a Entra ID, which is a Azure AD, the new name of Azure AD. Roles can come there as well in the form of groups. So that security model is saved in the configuration database of the system. Our particular case, and we call that a Galaxy repository. And then with certificates, workstations and servers are asked to join the SCADA system. If you don't get a certificate, you can't join. You can't, no matter how much software you put on that workstation, it can't become a part of the SCADA environment. So now you have control over which computers and which operating systems can even attempt to issue any sort of commands to the SCADA environment. The security system is synchronized amongst all these workstations so that everybody knows and every system knows who's allowed to do what. And it can enforce the security system independent of isolation. So if I can't talk to the domain controller, I can't talk to the rest of the system, these two computers can still perform authenticated actions. So when I log into this, I log in as myself, and then we go in, we validate ourselves against the Active Directory for the first time we ever do the login. And then it brings our credentials back, and it will provide that mechanism so that I can re-log in and log out now, just like I can with my laptop. Once I log in and I validate with my corporate domain controller, I can log in and log out of my laptop without having to be talking to the corporate domain, if that's the case. But then tokens of those credentials are sent then to every other workstation and server in the system so that everybody knows who I am and what I'm allowed to do. So when I issue a write, I issue a command to close this valve. The command goes to a state of pending, and then the destination evaluates that, yes, you are allowed to do that. It will then send the command to the respective device and then update my UI to make sure that I know that the command has been successful. With a secure to verify write, I can issue the same thing, and then it evaluates that and says, you need additional authentication. It goes to a state of security and then requires me to have a verified write. It can be user password verified, it can be two-factor authentication verified. And a secured write is the same thing, but now two people have to do it. But again, this is all selectable on a case-by-case basis. Obviously, not everything needs this level of authentication. A few things might, and having the tool there is important, right? So most control systems are not connected to the internet. And there's several firewalls that exist between the control system and the cloud. Now, to go to the firewall guys and say, hey, I need to punch in a 443 hole through all three firewalls, the answer to that typically is just going to be simply no. So Aviva has produced a component that is a downloadable component called DMZ Secure Link. And it basically allows you to route through the maze of firewall protection with a known endpoint and a known port. And then you move through this maze of intrusion protection. Eventually, you get to a place where you can establish a 443 connection. It's a single outbound only port. It will only allow the origination from the safe side of the firewall. All traffic is encrypted. It denies all inbound connection attempts. And it's basically an anonymous HTTP proxy. Now, anybody can make a forwarding proxy. You can go to in Nginx and download their forwarding proxy and build your own. Challenge is that you want to be able to encrypt that allow list so that you have a known list of endpoints, right? So Aviva actually does that for you. You can chain these guys together. And what this now does is it allows an MFA authentication from a control network that is not connected to the MFA authenticators. This is very, very powerful. And so as we move data into the cloud, right, you want to be able to share information from your control system to other non-control system users. Some of those users are within the business domain. Some of those users are actually at the level of the cloud. So when I read a sensor and I bring it in, I read some device, it's 35.4 is a pressure, and I bring it into my SCADA system, that gets now put in context. I now know what that is. It's tank A pressure 35.4. I then send that into, in this case, my historian, and the historian records it in a time series nature so that everybody on the control network can see it. But then I want to send this up into the cloud. So the first thing we do is that we take that payload of data and we break it up into two pieces. One piece is the metadata describing the tag name, location, scaling, units of measure, all the things describing that. What piece of equipment is it a part of? And then we route that up through our maze of intrusion protection and get that up into the cloud, save it in the cloud in a database that's encrypted. And then we take the values and reduce them to a number between 0 and 1. Attach it to a GUID, just like the metadata was attached to a GUID. A GUID is a global unique identifier. It's something that can only be generated one time. Once you generate a GUID, you can never repeat it, no matter how hard you try. And then this thing will then send it up and store it in a separate database in the same cloud, right? So now it's kind of like the way your credit card numbers are saved, right? You know, they don't save both numbers, the whole number in one place. They actually split it in two pieces. And then when I want to see that information, it's all put back neatly assembled for me. So on my phone, my browser, my tablet, whatever I'm looking at it from a cloud perspective, I combine those metadata and values together. But if I was able to break this communication link, if I was able to break through the certificates, which is very, very difficult, I won't say impossible, but all I would get is nonsense, because all I get is numbers that look exactly the same as every other number. I don't know their magnitude. I don't know the scale they have, right? It doesn't make any sense to me. And then because the cloud is a very powerful environment, it provides a lot of services, provides AI capability, business intelligence engines, a lot of great analytics that we can do up there, all kinds of interesting things that may be of use to our operational people. I can now consume that because I established this connection from the control domain. I didn't establish it from the cloud down to the control domain. I can consume it back down into the SCADA system safely, securely, with a minimal threat of intrusion. So as we look at this in summary, right, you want to never assume that a system is impregnable. Okay, you always need to be vigilant. Defense in depth is critical. Not one level of protection should be implemented, right? I should be looking at this system with vigilance and monitoring so that I understand when action needs to be taken. You should really understand what my threats are and understand how to mitigate those threats. And to just, design the system to be able to be robust against what's perceived as your threat vector, right? Understand where the vulnerabilities can be present. In a lot of cases, this is down at the device level. I should be able to design my networking segmentation and connectivity to those devices so that I know who's talking to them. Not anybody can just simply come into the network and make a connection to the device level. And then required, have a single point of disconnection. When I perceive a threat or something, right, the first thing I want to do is pull the plug. But pulling the plug should not disable my control system. I want to be able to still operate, even though a penetration of a higher level system has occurred. I want to be able to authenticate users. I want to be able to perform authenticated actions. And even in the control environment, if I have isolation of, say, there's only two computers left that are able to talk to each other, they should be able to authenticate and function independent of being a member of the rest of the mothership. So we think we have provided the capabilities for the defense that's required, right? We have certificate-based TLS 1.2, 1.3 encryption. The version of TLS is really controlled by the operating system. We actually don't have any control over it. User identification is transmitted with every write. So every time you issue a write command, who is issuing that command? Not just who logged in or who made the connection 3 hours ago. Every time a connection is made, it's transmitted with every write. So the receiving entity can interpret and decide if that write is accepted. We have a multi-path connectivity to the endpoint. A read path is independent to the write path. When I see a value on the screen, that's the value in the device. It's not the value I attempted to put there. Eventually, that may be the case, but so many SCADA systems are you push a button on the screen and instantly goes green to turn the motor on, and then 5 seconds later you hear the motor turn on. Right? That's not how our system works. It's guaranteed delivery of that command. So the system will attempt it until it can't, and then let you know that it couldn't do it. The graphics can be animated to reflect the read or write status that's currently going on. And that can all be done globally in the system, independent of graphic design. So it's able to manage those standards of how things are interpreted and behave, independent of the way we design the graphics. So as you have multiple teams working on graphics, this factor can be controlled on an application to application basis. Security is modeled and enforced at the attribute destination. It's one place to change it at, you can set up every VFD to behave the same from a security permission perspective. But different VFDs will have be in different groups, and people can be authorized to actuate different ones. All changes are logged by the destination right target, regardless of the mechanism used to make the change. If it comes from a protocol, it's logged. If it comes from an operator, it's logged, right? And this security model cannot be bypassed. Even if we even have a selection of something called the none security model, which is only recommended for testing and development purposes and playing around. But even in the none security model, the security model is still there. It's just that everybody all none means is everybody automatically logs in as the same user. We have the ability to enforce this security across multiple applications. We call those galaxies. And they're enforced as if the right was within the local galaxy. And a user must still have right permissions within the target galaxy for the right to be accepted. All right, questions?
Yeah, thanks, Mike. Great presentation. It looks like we've already got several questions coming in from the audience that I think we can spend a few minutes chatting through. The first one comes in from an anonymous attendee, but it says, given that the DMZ secure link is outbound only, what technology can be used to send data back from the cloud to the PCS?
Well, again, that communication is it's a TCP connection. So it once established, it has bidirectional capability, but the firewall can be configured so that connection can only be established from the control system. And typically what happens is the cloud sits there and just acts the receipts. Like it's sitting on the phone saying, yep, 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 right? You're not allowed to say anything more complex than that. You can just say, yes, I hear you. But you can then consume back down that established link. But because that link is only able to be linked to a known endpoint and only able to be established from the control system, it's as secure and safe as we can make it.
Makes sense. Wow, the questions are really coming in now. Okay, so next up comes from Ryan Kirkland. Ryan, thanks for joining us today. What kind of actions should you take in the event that non-authenticated access has been detected? And of course, Ryan understands that the answer is probably it depends somewhat, but what are some of the examples of actions that should be taken or could be taken in the event of non-authenticated access?
Well, I mean, obviously the first thing is an establishment of awareness of all the actors that everything is logged. Secondly, is that maybe you need to review the security configuration of that entity and include a multi-actor authentication on that. And really, I mean, this is what I consider to be the greatest vulnerability to control system design, is the authorized actor being forced to do something that they're not supposed to. There's really, I mean, obviously we have humans involved, and so you must be able to increase your level of authentication and authorization requirements on a case-by-case basis.
Right, makes sense. Another question here from Joseph Mazzola. Joseph, thanks for joining us today as well. Is a system with one connection from the control system network to the business cloud network with a firewall considered safe enough? And how would the firewall need to be set up to ensure security?
Yeah, so typically, like if you look at NERC-CIP requirements, they want a DMZ in between. And like if you read NERC-CIP explicitly, they'll say we even recommend that you have two different brands of firewalls, one on the top of the control system going into the DMZ and one on the DMZ going into the cloud or business connection. You know, and the reason for that is that you want to, if for some reason there's a problem with one of them, you want to be able to only have that communication go so far. But the other thing is that in the DMZ is where you want to put your access points. If you want to have, you know, remote desktop or some sort of web server or something that is going to allow a business user client to get at the thing. We didn't have enough time in this presentation to go through some of those techniques, but they need to be in a DMZ, not on the control network. So yes, if all you have is one firewall, then it's obviously better than nothing. But it's recommended that you at least have two and a DMZ in between.
Yeah, good best practice recommendations there. Another question here from an anonymous attendee. If I don't know anything about domain isolation, where would you suggest I get started if I wanted to pursue this with my company and it's and its IT department, which I suspect doesn't really know much about that side of it either. So any recommendations kind of on?
Oh, I mean, so, you know, it's a big word, but it really is a simple concept. It's simply that I have a separate set of users for my control system than I have for the business network. So, you know, the people that are just accessing email or, you know, Excel or Word or things like that, their login works in the business environment. It does not work in the control system environment. Now, that's probably, you know, every IT department, I've never met one that doesn't know how to do this. It's just that it's more work. All right. And they don't want to put the work in, right? So they say, well, everybody's going to be the same domain. Well, you know, that's just, I consider that to just be a mistake. You should have, and NERC-CIP does too, right? They say you should have, you know, NERC-CIP is critical infrastructure protection. So they want to have a separate set of users that are allowed to manipulate the control system environment, that are independent of the business users. And that's just setting up a second domain controller, a separate set of user authentications that exist independent of the businesses.
Yeah, great points. Another question here for you, Mike. For sites that require remote access for control system support, is the architecture safe enough to use the same connection, or would terminal server be required?
Well, terminal servers have, if you're using just raw RDP, that's a really discouraged mechanism these days. You know, few organizations, few IT departments will allow RDP connections into their environments. So, yeah, no, I really don't recommend using terminal servers for external access. You know, if you're inside the control system and you want to distribute desktops or keyboard, mouse, and video to various other workstations from a central server, great. But for external access, really recommend using a much more secure mechanisms, such as a web server, which is HTTPS enabled, that can encrypt that communication and provide a much more robust mechanism. But from the concept of I have distributed nodes, then you know, the certificate-based model is what ensures the security of that. You know, as I said, even if I take ports and restrict the number of ports that I'm allowed to use, you know, Aviva's had a industrial protocol called SweetLink since, you know, the early 1987 timeframe, and it uses one port. Is it secure? No, it's not, because without certificates to secure it, it can't be secure.
Sorry for interrupting. I just wanted to remind you to please put up your contact slide. Mike, I know we have more questions, but while you're answering them, might as well do that. I thought you had one.
Oh, let me just add my contact information.
Yeah.
That's all right.
because I do see there's another, oh yeah. So can you share this presentation or link to review this webinar? So we will send out a recording of the webinar probably the next day or so. Give us a minute for various reasons on the back end, but we will send out a link to the recording so you will have that. And I know there's still more questions here. I'm gonna go back into my trash can in a minute and let you guys fill that out. Just wanted to make sure that people had your contact info in case they wanted to talk to you kind of offline.
Yeah, thanks for that reminder, Lisa. So yeah, do please reach out to Mike with any questions. I know a lot of times in these presentations you may come up with a question after the fact. So happy to answer questions post webinar. But one question I wanted to ask you, Mike, we don't get a lot of time to dive into some of the really cool use cases and experiences and applications that you run across out there. But I was curious, going from something like our InTouch Unlimited offer, where you've got unlimited tags, unlimited users, et cetera, et cetera. Those are typically designed for very small applications that may be, I would say, less complex. But when we get into some of these larger applications, could you talk a little bit about some of the use cases that you're seeing as far as sharing data from different sites and maybe kind of take a cybersecurity perspective on it, if possible. But I'm curious what you're seeing out there as far as the use cases that are requiring data to be moved from maybe one physical location to another. Maybe something that would help our attendees today kind of trigger in their mind, when I see this type of use case, that's really when I need to be thinking about cybersecurity.
Well, okay, I'll say that you need to think about cybersecurity if you're a single node application. All this stuff works from a single node to hundreds of nodes. So as you move into a informational sharing environment, one of the things that we do is with getting data to a user community. We use tiered historians to do that, and that gives us the ability to a tiered historian is a single port connection. It's an outgoing only port, so you have nothing on the in the incoming side of the firewall, and it will then push all that data and configuration of that data to a second historian, where it's a read-only environment, and you can fold, spindle, and attempt to mutilate it any way you want, but it's not gonna be impactful on the control system's operation. We also, and that's typically within the environment of the client or customer. And that's the other thing that Connect is for. Connect is the ability to send data into a cloud and take a portion of that data and say, hey, this vendor, this supplier, this customer that's a relationship with ours is able to see this piece of information.
Okay, great. Good background there. I think we're getting to just about the end of the questions. If anybody in the audience has anything additional they want to type in, we'll give you
Did
just,
you address, there was one that said, what about Access Anywhere that is based on terminal service? Forgive me if you've answered it, and forgive me.
No,
if
I have
you
not. I did not
Okay.
answer that. So yes, you're right. Access Anywhere starts off with a terminal server, but what it does is it puts in HTTPS proxy on top of that terminal server. So I'm not making an RDP connection into the terminal server. I'm making a secured HTTPS encrypted link into there, which then internally gets converted to an RDP connection. So that provides the mechanism where you don't have to expose an RDP connection to an external client.
Okay, great. Thank you, Mike. I think, Lisa, that is the end of the questions as far as I could see on my end. So I think at this point in time, we can go ahead and wrap up. If there's any closing thoughts you wanted to leave us with, Mike or Lisa.
I do, but Mike, you go ahead if there's anything else you want to say.
No,
Or
I'm good.
they speak now or forever hold your peace.
Yeah.
Okay, so I do have a couple of slides, and my colleague's gonna pull those up for us. I just want to kind of wrap things up with just saying, thank you to our speaker for this discussion, and also to Aviva for sponsoring this event. And of course, thank you for attending. I would like you to bookmark the CSIA events calendar though, so you don't miss any upcoming events. And that's a wrap. Once again, thanks for joining us and have a great day.